I'm Andrew Smith, aerospace engineer and finalist of the Great British Bake Off, and today I'm going to be using baking to explore the extraordinary engineering behind the everyday material we take for granted, concrete. From the Shard in London to the Burj Khalifa in Dubai, concrete is a ubiquitous material now. But from its usage in Roman times to today, engineers have had to be a little bit crafty to enable us to build taller, bigger and stronger structures. But first of all, what is concrete? Concrete is made up of aggregate, which is basically just small and large rocks, and is bound together by cement. Now, what's really important about concrete is on its own, it is a brittle material. So under the microscope, it's made up of lots of little crystals. What that means? In compression, so when the material is being pushed together, it's really strong. In tension, when it's pulled apart, it's very weak. So when we think of a bridge, if you put a load on top of that, the bottom surface is pulling apart in tension and the top is pushing together in compression. That means if we're just building with concrete, we're going to have a very thick and expensive bridge. What else is like concrete? Caramel. I've got my sugar there, and then I'm going to add in some cold water. And then I'm going to pop on my hob. So I've got my caramel bar here. Just melted that down, cast it into a bar, and now we're going to test how strong it is. So I've just got 4 little pots here, and this is my caramel bridge. So this is the pure concrete example. And this is a low-tech demo. You can do this at home. I've just got a bolt. You could drop anything solid on this, but watch how easily this shatters. So you see, absolutely shattered. And if you look at the side of these surfaces, it is glassy and sharp, and just like a broken pane of glass. So not much height at all, and the whole thing failed and fell apart. Caramel is brittle, concrete is brittle. What can engineers do to make it stronger without making it a lot heavier? Well, we use the idea of a composite. A composite is where we take 2 materials and use the best of their properties to make a material that is greater than the sum of the parts. In concrete, this is with reinforcement or steel bars. Now, to show you how this works, I've just got really simple wooden blocks here, and these are the crystals in my concrete. So on their own, if I push them together and lift them, they fall apart. They can't form a bridge because they're poor in tension. If I want to lift them, I have to really push them together so that when there's load on top, it still remains strong. The way that reinforcement works is it takes steel, which is good in tension, or here my elastic band, wraps it around the base of my bridge. I can lift it, and when there is load on top, the elastic band or the steel takes the tension, and the concrete takes the compression, making the best of both materials and making a lighter, stronger structure. So with concrete, we do it with steel bars, but how on earth do you reinforce caramel? Well, something ductile, stretchy, strawberry laces. So that's exactly what I've done. I've welded on some strawberry lace reinforcement onto the bottom of my beam. You can do this at home too. You just winch them through the caramel. I'm going to put those on the bottom surface of the beam because that's the one that's in tension, so that's where I need the reinforcement. And let's see if it does the job. So you see that is shattered, but it's holding together, so it is still a solid beam. And it's got those little cracks, but it's not caused the whole structure to fail. And in real concrete, we have these tiny cracks that form, but they don't propagate through the structure and break it because of the reinforcement, and that's what keeps it safe. So if I bend this, you can see those strawberry laces are acting like a hinge. They're absorbing that tension and that energy. And they actually fail in a very similar way to steel. They get thinner and then they break in the middle, something called necking. So a composite caramel reinforced beam. much stronger than the pure caramel one. So next time you see an epic skyscraper or a gigantic bridge span, think back to your favourite sweet treat and the humble caramel. Thanks for sticking around to the end of the video, guys. Hope you really enjoyed it. If you did enjoy it and you want to see more, don't forget to like and subscribe below for loads more content. And if you do want to find out more about FameLab, click that in the link below as well. That's the end of the video.